Okay, so today starts part 2 of our lesson on 7.3, finding the probability of a compound event, using example 2. So you're going to refer back to that table from example 2 that showed you a number cube, 1, 2, 3, 4, 5, 6, okay, back in example 2, and flipping a coin, heads and tails. You guys see that table back from example 2? Okay. So I can see all of the possible outcomes. So from a tree diagram, I can calculate my probability by using the total. Remember, probability, let me just review with you real quick. The probability that an event happens is favorable over total. Favorable over total. Okay? So the difference in this lesson is they're not going to tell us the total. But in example 2, I calculated the total by the fundamental counting principle. There were 6 number cube choices, and there were 2 possible outcomes for the coin, so 6 times 2 was 12. You guys remember how I did that? 6 possibilities for the number cube, 2 for the coin, 6 times 2 is 12. So in order to calculate this probability, it's going to be out of 12. But I calculated that, okay, using the fundamental counting principle. So here's the question. How many, it's got to be both, okay, it's got to be both of these. How many possibilities are greater than 4 and also tails? So that's the compound piece to it. It's got to be both. What's the matter? Huh? Okay, give me one outcome that is greater than 4 and tails. 5 tails. Does that meet both criteria? Is that greater than 4 and tails? Yep. What about another one? Is it or any others or just that one? 6 tails. So out of all those possibilities, 5 tails and 6 tails matches both targeted outcomes. So 2 out of 12, which is 0.16 repeating. So I would say about 17%. If you said 16.6 repeating percent, that would be fine. Okay, so I calculate probability. There's a couple twists here. For the favorable, both outcomes have to happen. And for the total, I'm actually calculating that. It's not telling me the total anymore. I have to use the fundamental counting principle. Now let's look at the next one. What's the probability of rolling at most 4? That's something I haven't seen in a while. And flipping heads. Okay, so it's got to be both. It's at most 4, so the number is at most 4, so figure out how many numbers match that criteria, and then also heads. Probability of 4 and then heads. All right, give me one favorable outcome that matches both criteria. Anybody give me one?
5 heads. No, 4 heads.
4 heads. Okay, 4 heads. Because at most 4 means it can be 4 and heads. So that matches both things that I'm looking for. 4 heads. What's another one?
3 heads.
3 heads. 2 heads. 1 head. That's not an option. That's not a number on the number cube. Okay, so how many favorable outcomes are there now? 4 out of 12. But you see, guys, it has to be both. It's got to be both outcomes. All right, there's a possibility that I could flip heads and roll a 4. I could flip heads and roll a 3. Those are favorable outcomes. So that's going to be 1/3 or about 33%. Okay, just calculating that probability. Okay, and that's rounding, it's a repeating decimal. Okay, so really to calculate probability, compound probability without a formula, I have to be able to see the possible outcomes. I've got to be able to see that. All right, so in example 5, it says, on a game show, you choose one box from each pair of boxes shown. So up here on the screen, you can see that they're colored. I know in your notes they're black and white. Out of my 2 red boxes, one has a prize in it and one doesn't. And no, you can't walk up and shake it and figure out which one has the prize, okay? So you just have to trust me. One has a prize and one doesn't. So let's say they're all in a row. I go up to the red. I can choose one or the other, right? Then I go to the blue. Well, I've already picked one from red. Then I go to the blue. So in order to be able to answer this question, you have to calculate, or you have to draw a tree diagram, all right? So based on the presents over here, and really you can start with whichever one you want. I'm just going to start with the top one with the red, okay? And in the red presents, I have one that has a prize and one that does not have a prize. So I'm just basically choosing letters that would stand for that, prize and no prize. I may run out of room. We'll see how this works, okay? Then I have my blue category. So let's say I chose the red one with a prize. Well, then when I get to the blue ones, I have 2 choices here too. One has a prize. Actually, I guess I could keep the same order. One has a prize and one does not have a prize. So there's a chance I could pick. In the first one, I could pick the prize, and in the second one, I could pick the prize, right? But there's also a chance I could pick the prize from red and then no prize on blue. Well, what if I start off picking the one with no prize on red? Well, I could still pick the one with the prize on blue, or I might strike out again and pick no prize again on blue. All right, this guy's unlucky down here, right? Okay. All right, so now I've got my green. Now I'm to the 3rd group of prizes. So guess what? Maybe I picked blue. Prize, well, for the green, I could pick prize or no prize. So do you see how it keeps kind of splitting? All right, and then maybe I picked no prize on blue. Well, green, I could pick prize or no prize again. It's getting a little squishy over here. Prize, and then I could pick the prize or the no prize. And then no prize, I could pick prize or no prize. Okay, so they just kind of keep splitting. So now here are my outcomes. Definitely abbreviating these, okay? My very first outcome, there's a possibility that I go down the row and I pick a prize, prize, prize. I pick all 3 presents that had the prize in there. There's a chance I could do that. Okay, what would be my next possible outcome? Prize, prize, none. Prize, prize, none. I would still say that's a pretty good outcome for you, right? 2 out of 3. Then I could go prize.
Prize, no prize, no prize.
Okay, so I did PPP and I did PN. Now I go prize, no prize, prize, PNP. Now I go prize, no prize, no prize. Sad times for that guy. All right. Now I'm going to go down to, well, what if I picked this bottom tier, no prize on red, but then 2 prizes.
That's the same as the one up there.
But not in the same order. So this guy walks away with a blue prize and a green prize. That's a great observation, though. This guy walks away with a blue and a green prize. The first guy walked away with a red and a blue prize. Okay, so it still is different. So NPP, and then we go NPN. No prize. So this guy, he won the blue one, right? He won the blue one. All right, NPN, and then NNP. And then what's the last one? NNN. Super sad day for that guy, right? Okay, so now that I have my outcomes listed, this is the only way that I can answer this question, to actually calculate and be able to see these are the possible outcomes. Now I can answer. What is the probability of winning at least one prize? How many of these outcomes came away with at least one prize?
All of it except for one.
Yeah, all of them except for the last one, right? The last one was no, no, no. They went through and picked literally the wrong one every time. So that would be how many? 7 out of how many total? 8. Okay? So what would be those odds? What would be that probability? What is 7 divided by 8? Okay, 87.5%. So I'm going to ask you a question now. Would you like, it's like $5 to play the games at the fair or whatever. Would you pay the $5 to play this game?
Yes. What's the prize?
Why?
Because it's so easy to win a prize.
Because really, on paper, if one has a prize and one doesn't, it should be like a 50-50 chance, okay? But because of all the different combinations, I actually can see that my chances are even higher than that, okay? Possibly 87.5% based on these outcomes. Okay, how do we do on that? Do okay? All right, I want to look at a few homework problems. We kind of left off roughly on number 18 yesterday. And I said, save that calculating probability for today because I wanted to work through that with you. All right, go ahead and turn in your books to page 305. Page 305. I'm going to keep this on the recording also. The homework really just gives us a completely different perspective or viewpoint on calculating compound probability. This is more along the lines of what you would see on a quiz or test. Okay, don't you love it when the example doesn't quite match up with the homework problems?
Yes.
You know what I'm talking about? Okay, so go ahead and turn in your books to page 305. And let's finish up the homework too. Okay, so you should be open in your book to 305 and then also turn in your notes packet to your homework page. All right, let's look at number 20. Number 20 says, you spin the spinner and flip a coin. Find the probability of the compound event. Okay, well, in order to calculate probability, you have to have favorable out of total. There is, we're number 20. Okay, I'm sorry. No. Sorry. I literally said number 20 and then I read the instructions below it. So, number 20, you roll 2 number cubes. What is the probability of rolling double 3s? Okay, so again, you have to have a total amount if you were to calculate probability. I actually dropped a little hint on this a few minutes ago. Caleb caught it.
What kind of number of 30?
How many possibilities are there on one number cube? 6. How many possibilities are on the other number cube? 6. So fundamental counting principle says take the possibilities and do what? Multiply them. What's 6 times 6?
12.
Yep. It's okay. 36. It's okay. All right, 36. Now I need to figure out how many combinations, okay? So how many 3s are on a number cube? 2. Just one on one number cube. So on the first one, I could roll a 3. But on the second one, I'm just going to roll a 3. There's only one outcome that would be double 3s. Now, if I had asked you, what's the probability of rolling odd numbers, then it would be more than 1. But because there's only one 3 on the number cube, it's only going to be 1 out of 36, okay? Even though it's on 2 different ones, remember, the favorable outcomes has to happen on both, okay? So in order for it to be a 3 on both, that's only going to happen one time. Do you see that? So you almost view it as like together. It has to happen together. All right? That's not going to be very high odds. What is that as a percentage?
2.8%.
2.8%. You're going to be sitting there a long time if you're trying to roll double threes. Now, what is it, Monopoly? If you roll doubles, you get to go again? Yeah, you roll doubles 3 times, you go to jail. Okay. So rolling doubles, especially if you're trying to roll a specific number, that probability is going to be really low. Okay. Now look at 22, 24, and 26. And this is actually where I'm going to stop the homework assignment. I know we were going through the next section, but just time-wise, we don't have time, and we're okay just on this section as far as the important concepts. All right, so 22. You spin the spinner and flip a coin. That spinner right there on page 305. Find the probability of the compound event. Both events have to happen. Okay? So, first of all, I need, please don't say it out loud, I need a total. There's something here in the instructions that would hint at what that value would be. Go ahead and write that number in for your total. Okay? I want to give you a minute to try to figure it out on your own. All right, remember, this is technically a homework grade, so we're doing it together, but I want you to try to figure it out also. Anybody know the total? Joel? No. Colin? Yes. How did you figure out 10?
There are 5 spots on the spinner, and
Mhm.
there are 2 spots on the coin. So
Okay.
5 and 2. Oh.
Fundamental counting principle. There's 5 possible outcomes on the spinner and 2 on the coin. 5 times 2 is 10. There are 10 possible outcomes here. But how many of them, so now let's look at number 22. How many of them could be spinning an even number and flipping heads, okay? So how many even numbers do I have on the spinner?
2.
2. Is it possible for me to spin a 2 and flip and land on heads?
No.
Oh yeah, I could spin a 2 and flip and land on heads, or I would spin a 2 and flip and land on tails. It's going to be one or the other. So 2 heads is one favorable outcome. Is there another favorable outcome? 4 heads. Okay? But any other, yeah, sure, I might do a 5 heads, but 5 is not an even number. So there are 2 favorable outcomes, which is 1/5, which is 20%. Okay? There are 20% odds or chances that you would do both. I want you to go ahead and answer number 24. And I don't know why they put these in there, but they do. What's your probability on 24?
0%.
Yeah, there's no 6s. 0 out of 10. What would I say about the likelihood?
Impossible.
Possible. Very good. Ready for your quiz today. Okay, number 26. Okay, what's your total on 26? What's your total? What goes in the denominator? It's not a trick question. Yeah, it's still, guys, it doesn't matter what scenarios they're throwing at you. It's still the same overall scenario. 5 spots on the spinner, 2 spots on the coin, 10 is my possibility. Now it says spinning a prime number. Oh my goodness, what is a prime?
Oh, I remember.
Is 1 prime?
No.
Nope.
It's 2 through prime.
It's neither prime nor composite. So 1 is out. What other prime numbers do you see?
2,
3, 3, 5. Can I flip a 2 and then not flip heads, which means I flip tails? Yep, so that's one favorable outcome. Is there only one favorable outcome though? No, because then I could go, give me another favorable outcome.
5
Not 5 heads. 5 tails. And 3 tails and 2 tails. So how many favorable outcomes are there? 3. Okay. So that's 30%. Do you see how we did that? In order now for an outcome to be favorable, both events have to happen. Okay? Both events have to happen. All right? Okay, that's everything you need to know for 7.3.